Okay, everybody, today we're going to be going over the Unit 2 study guide for the Unit 2 test. This is going to cover biochemistry. So this is Unit 2 test review. All right, number 1, what are monomers and polymers? You do not have to answer how they are formed. So, Aiden, what are monomers? A monosaccharide is an example of a monomer. I want to know what the general definition of a monomer is. A monosaccharide is a monomer for carbs. So you told me an example of one. I need to know the definition of just monomer. That's like if I were to say, what is a human being? And someone said, Aiden. Aiden is an example of a human being. Like, what is a human being, though? Can you answer that? What is a monomer? Put down the wrong answer. So you don't remember what we talked about in class? Ladies, you want to give them an assist? Race?
A small single unit.
Small molecule that serves as a subunit or building block for a larger molecule. And so, Jack, what do you have for polymer? What is polymer? That's pretty much says it, right? Large, how about large complex molecules? Composed of monomers. So Aiden, if my floor is a polymer, what are the monomers? Look down at the floor. What is it made of? Okay. If my wall over there is a polymer, what are the monomers? If I had a Gasparilla necklace and that's a polymer, what are the monomers? Yep, got it? Okay. Number 2, what are the 4 types of macromolecules and their properties or functions? So Chris, tell me one macromolecule. You don't have to go in the typical order, and tell me what their functions are. Proteins, okay. Well, you picked the fun one. There's 6. 6 possible ones we talked about. Can you at least name 3? Defense, all right. Antibodies. Structure. We're going to say supports. Yeah, support. Actin, or not actin, myosin. Support's going to be keratin, collagen in your skin. Go on. Metabolism. Enzymes break things down. Regulation is going to be hormones like adrenaline. 2 more. Transport is going to be hemoglobin, transporting oxygen throughout our blood. And motion. Actin, myosin, they make your muscles move. When your muscles are relaxed, actin and myosin are not engaged. When your muscles are being used, they are engaged. Okay, so proteins. Thank you, Chris. Sloan, tell me another one. Okay. All right. Stores and transfers in our genetic info. And what does RNA do? You described DNA. What does RNA do? Synthesizes what? How'd you know? Synthesizes proteins. All right, 2 down, 2 to go. Hannah, give me another. Carbs. I'm just going to write carbs since we're on limited time. Carbohydrates, also known as sugar. What's it good for? Yes, it is. Anything else? Protection, cell walls. Very good. Real quick, bonus question. Grace, what is the cell wall of a plant made out of? What carbohydrate? This is an AP Bio question too. It is. And Mr. Thorson warned you that the further away we get from Unit 1 in AP Bio, the harder it gets, right, Chris? Yeah, right, Sam? Right, Hannah? Yeah. No, think corn. Scout? Cellulose. What is the cell wall of a fungus made out of, Isabella? Chitin. What is the cell wall of a bacteria made out of? Anyone? Hannah? Peptidoglycan. That's what we mean by protection. Do animals have cell walls? No, we are the exception. Fungi have them, bacteria have them, plants have them, animals don't have them. All right, the last one we're missing is lipids. I'm going to take this one. This is long-term energy. Fat deposits, insulation, and hormones. Hormones like testosterone and estrogen are called steroids. Steroids are lipid-based hormones. They're hormones that are nonpolar, namely the structure of lipids. Okay, so that was number 3. Let's move on to, that was, why did I put 2? Is that 2? That was 2. Jeez. All right, number 3. This should be easy. Let's just keep it here. Let's do proteins. What are the elements found in a protein? There's 5 of them. Eva. For proteins, it's carbon, hydrogen, oxygen, nitrogen, and sulfur. Tyler, what about a nucleic acid? I'm looking at you, wrong one.
Carbon, hydrogen, oxygen, nitrogen,
Dan, what are the elements found in a carbohydrate?
carbon, oxygen, nitrogen.
Is there a ratio?
Was it 1, 2, 1?
Yes, it is. And Dylan, can you tell me the elements found in lipids?
Carbon, hydrogen, oxygen.
Is there a ratio? Which way? No, there isn't. What element is very scarce in lipids? Oxygen. Okay, good. Now we're on to number 4. Let's just keep this columns here, guys. I'll do this. Check this out. Number 4, I'll put M for monomer, P for polymer. Okay. The first column is going to be proteins. What are the monomers of proteins, Scout? Amino acids. Very good. What are the polymers called? You did it. You did the mistake I warned everyone about. You connected amino acids and nucleic acids. I don't make this up. Try again. Peptides. Peptides close enough. And what do you call multiple peptides? Polypeptides. Okay. Nucleic acids. Sam. Yep. DNA or RNA. Okay, carbohydrates. Melanie, what are the monomers of a carbohydrate? Monosaccharides. What are the polymers called? Yeah. Okay, last one. Noah. Dude, you're killing me. In fact, I told you guys this. How should you respond when I ask you what are the monomers of a lipid? Which one? Oh, Eva, triglyceride. Let's do that one. What are the monomers of a triglyceride? Nope. You just said the monomer of one polymer is another polymer. No. Isabel, you know this. And? Yep. A glycerol plus 3 fatty acids. Okay. Now, if I were to do a phospholipid, what?
for Lancaster.
That was last period. What, Eva, you redeem yourself here. What are the monomers of a phospholipid? Think of the name, phospholipid. Chris? Phosphate and 2 fatty acids, 2 lipids. Eva, knock, knock. Test tomorrow. Yes. Jackie.
I thought with the phosphate there was 3 fatty acids.
Nope. Triglyceride. Phospholipids is 2. Okay. Number 5. What is the difference between a saturated fat and an unsaturated fat? And how does this difference affect their properties of the molecules? Let's do a saturated fat first. Go ahead, Grace, enlighten us.
A saturated fat has more hydrogen
You're right about the first one.
and then has no double.
That's better. Good save. So a saturated fat has the maximum number of, why did I say hydrogen bonds? Just hydrogen, has no double bonds between carbons. And what state of matter is it?
Solid.
Solid at room temp. Okay, unsaturated fat. Alyssa, tell me about an unsaturated fat, please. Does it have the maximum number of hydrogen or less than? Less than. What state of matter is it at room temp? Oil, liquid. So it has less than the max number of hydrogen. It does have double bonds between carbon. And it is liquid room temp. There's actually, I told you guys there used to be a store at International Mall that was all oils. Turns out there's been one on Beta Bay for a while. It's called Joel and Sons Olive Oil. Has anybody been there? Yeah, it's like all oil. They got oil from every plant you can think of. Okay, number 6. How are triglycerides, phospholipids, and steroids similar? How are they different? Well, what class of macromolecule do triglycerides, phospholipids, and steroids belong to? Are they carbs, lipids, proteins, and nucleic acids? Melissa? They're all lipids. So triglycerides, phospholipids, and steroids are all lipids. If they're lipids, does this mean that they are polar or non-polar? They're non-polar. Fat and water don't mix. And composed of the same elements. How are they different? Well, they all are very different in their structure. They have very different structures. In Scout, because their structures are different, what would that say about their function? Yeah, their structures are very different, which means they have different functions. Steroids are hormones. They treat me, guys, you have testosterone, males. You have a lot of testosterone. When you were in 6th grade, you probably said, "Hello, everybody. My name's Chris Parno." And now he's a senior. He goes, "Hi. Hold on, let me scratch my beard. I'm Chris Parno." Huh? Testosterone. Girls, estrogen. That's a fat-based hormone. Phospholipids are a fat that build your plasma membrane. And triglycerides is just like body fat. If you get it in your blood, it can clog up your blood vessels. Take it easy on the milkshakes and the cheese. Okay, let's move on to the vocab. Now I'm going to switch over to Microsoft Word. We're going to type it up. It'll be a whole lot faster. Hopefully I won't have too many typos. Let's switch on over. All right, hydrogen bond. A hydrogen bond is an intermolecular force between a hydrogen and either a, anybody remember the three other elements that could be on the other side of the bond? What's one? You could be either have an oxygen, hold on, there's one typo, oxygen, nitrogen, or fluorine. Very good. They are found in water molecules and DNA. I want you all to take a look at my little DNA model up here. What are the hydrogen bonds? Is it these yellow bonds in the backbone of the DNA? Or is it these white bonds that are holding the nitrogenous bases together? Which one? Grace? No, the yellow ones are the covalent bonds. They're on the backbone of DNA. Those are not supposed to break. Think of it like this. Everybody look up here. Is this supposed to happen to DNA? No. Is this supposed to happen to DNA? Yeah. That should happen. These white little thingies are the hydrogen bonds. It's the same type of bond that holds one water molecule to another water molecule. All right. Let's do a monomer. Aiden, you get a chance to redeem yourself. What is a monomer? Okay. Dan, what's a polymer? Let's say a large molecule composed of what? Right. A lipid. A lipid is a non-polar macromolecule used for insulation, long-term energy, and some hormones like testosterone and estrogen. Those are steroids. All right. Next, carbohydrate. A carbohydrate is a macromolecule used for short-term energy and protection. What is another word for a carbohydrate, guys? S word, 5 letters. 5 letters. Sugar. And technically, you're not wrong. Saccharide means sugar. Okay. Next, we have protein. Protein is a macromolecule. Oh boy. Used for, let's see when we get all 6. Transport, defense, metabolism, regulation, motion, and don't tell me. Defense. No, I already did that. Oh, you told me. Support. All right. You could skip dehydrate. Oh no, we're still nucleic acid. This is a macromolecule used for storing genetic info and synthesizing proteins. You could skip dehydration, synthesis, and hydrolysis. The last one is functional groups. Functional groups are small groups of atoms that can give a larger molecule a different function. I like to think of a functional group as a video game. You put the video game into a PlayStation, the PlayStation plays something entirely new. You want to play Sonic, play Sonic. You want to take it out, play Mortal Kombat, go for it. How about Halo? Fine. Final Fantasy, put in the CD. By the way, if anybody wanted to try to challenge me in Smash Brothers, you will regret it. Noah, you want to play that game? You know why? I wouldn't want to play it either against me. Anybody know how to play Smash Brothers in here? Dude, bring it. Bring it on. Samus will blow you off the stage. All right. Let's go back to the notebook. I'll let you guys see some pens moving, so I'll just give you a moment to catch up. By the way, this class is over at 1:40. It's 1:36. It's or 1:34. We have 6 minutes. It's going to be a close one. You ready, Hannah? All right. Let's go on to practice now. Okay, practice number 7. Draw 3 water molecules, identify their partial positive and negative poles, and then link them together with hydrogen bonds. 1 water, 2nd water, 3rd water. And so we have a sense of direction. I'm going to label these 1, 2, and 3. What atoms on a water molecule are considered to be partial positive? Grace? Hydrogen. So that letter that I'm drawing is the lowercase letter delta. This means partial, and the oxygens are partial negative. Okay, now how do they link? Scout, how do I get water molecule 1 to link to water molecule 2? Okay, so you have a hydrogen bond between the hydrogen of molecule 1 and the oxygen of molecule 2. And you do the same thing between number 2 and number 3. Big question. Can you link 1 and 3 together? Is there any chemical way to link those 2 together, or is the answer no? The answer is okay to be no if it's no. Isabella? No, you can't link 1 and 2. Or sorry, 1 and 3. Those are not going to be together. All right. Number 8, explain how the structure of water molecules account for each of the following properties and explain one way that each of the properties are useful for living systems. The first one is cohesion. Cohesion basically means water attracts water. Melanie, what is the majority of your blood made out of? Water. And so water sticks together. You may never heard it described like that, but water is sticky. And so water bonds to other water to stay together, like in your bloodstream. So all your blood is flowing together. The next one is adhesion. Adhesion is water attracts other polar surfaces. An example I could think of would be your blood vessels. The inside of your blood vessels is polar. So blood is attracted to them, it stays in them and continues to flow through them. Yeah. That's another great example. I was trying to keep it more like anatomy, but biologically, yeah. Water going up the stem of a plant, the xylem, perfect example. That's adhesion that is sticking to the xylem, and cohesion that's the water staying together. And then we have high specific heat. Running low on time, guys. Whatever we don't get to, be tough press. I might do it next period. High specific heat. Let's see. This is water's ability to absorb a lot of heat without changing its temperature. Now, this is very important for life. Very important. If it's 120 degrees outside, is your internal temperature going to be 120 degrees? No, because your body is mostly water. You're 2/3 water. The water is going to absorb that heat and try to regulate it so that your body temperature doesn't change. Now, eventually, if it gets too hot outside, yes, you will get things like heat stroke and heat exhaustion. But your body's supposed to absorb that heat to a point. All right, I'm gonna have to pause there. Listen up, guys. I will try to finish this in my next period. If you listen, please. Number 9 is on the Friday notes. Number 10 and 11 are on the Thursday notes. Actually, no, flip that. Number 9 is on the Thursday notes. Number 10 and 11 are on the Wednesday notes. That's what I meant to say. Please bring those nucleic acid papers back with you tomorrow so that you may get credit for them. Don't lose them. Someone in here is going to lose it. I feel it. Prove me wrong. Go to anything and go to study. Or Jackie, school day. Yeah. We'll do like right now while I get them the papers myself. So sit over there on the other side of the room. Are we getting it back? No, you stay. I still have people that don't. Oh, really? Thanks. What about the test? Test about the Don't get comfortable, you're all good. Except for Anna Sophia. What?
Do we turn in our study?
No, don't turn it in. Don't turn it in. You guys get your study, you guys study. All right, you all get some new seats because you know a lot of schedules change today. So listen for your name and your number, okay? Here's 1 through 10. Anna Sophia 1, Kylie 2, Caitlin 3, Emma 4, Nikita 5, Lily 6, Emma 7, Alex 8, Gwendolyn 9, Tamis 10. Lefty 20, Aubrey 11, Isabella 12, Julia 13, Madison 14, Mia 15, Andre 16, Morella 17, Shane 18, Emma 19, Cooper 20. Maria 21, Mackenzie 22, Nathaniel 23, Lance 24, Alexis 25, Sebastian 26, Mara 27. Yep. 5. No numbers up there. Okay. 1, 2, fire drill experience. Go out 4 times. Always go all the way to the screen. Right, students just doing a makeup quiz. Is there anyone else in here that needs to make up the syllabus quiz or a test? Okay. Aubrey, what do you have to make up?
I'm trying to aim so but there's no grade.
Nobody has a grade because that's a lot of students out of time.
Then we made it 1 time. So today,
Yeah, did you get my text?
yeah.
Thank you for the Julia. That is, what do you have to say?
You put it on the.
Actually, should be really quick. Okay, now, what you guys are going to do now is I'm going to pass out some work for you. Lance, I've already got your stuff. I'm going to pass out some worksheets to you. You probably want to use these to study, so you can be ready and go tomorrow. Fire alarm rings. Here's what I'm going to tell y'all. Study guide review is going to be on YouTube. You probably will need to watch that if you want to get ready for tomorrow. All right, help me out. Andre, Morellis, Mia, Maddie. Maria, Sebastian, Mackenzie, Cooper, Kate, Oliver, Bella, Mangione, oh, she was 5th period. Thing. Julia Miller. That's back. Julia, this might be yours too. Staple papers. Wait, no, that's not. That's it. I don't know. Ida. Anna Sophia. Emma. Put it on the box. Emma Karananana. Lily. When? Great. All right, now listen, I have not put those papers in Canvas yet. So don't lose them. I need you to bring those nucleic acids worksheets back to me tomorrow. Put them back in the box along with your study guide so you guys can get credit. I think you would enjoy that credit. So you can take some. Yep. Great class. Again. Fire drill. All right. I'm going to pass back your carbohydrates paper now. Or actually protein. Scouts. Morellis. That's back. Maddie. That's back. Mia. That's back. Bella. Julia. Kate. Back. Andre. Sebastian. Nathaniel. Gwen. James. Cooper. Nikita. That's the correct Maria in the back. Emma. Caitlin's absent. Lillian. Yep. Second period then. Fine. Right here. Remember Bellman in here?
Yep.
Some of that name.
Yeah, I remember.
You read that?
Yeah.
All right. When? Yeah. Andre. Kate. Patty. Mia. Julia. Bella. Alice. Sebastian. Nathaniel. Maria. Nikita. Lily. Emma. Caitlin, not here. Emma Newman, much better. Denise. William Abel. Anna Sophia. One more, guys. All right, last one. Lance and Kylie, I've got 2 papers. When? Yeah. Yeah. Emma. Lily. Emma. Caitlin, not here. Lily, second period. Connor, or excuse me, Cooper. Cooper. Denise. Alexis being here. Good period. Find out who the winner. Sebastian. Nathaniel. And Sophia. Bella. Mia. Morellis. Andre. Julia. Kate. Maddie. Maria. And. Ashbaugh. Thompson. 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 Ashbaugh. Ashbaugh. All right. Wow. Hey, kiddies. Bring back that nucleic acid worksheet tomorrow. All right, we're going to go until they alarm us out of here. We'll go and lock the door now. Okay, here's what we are going to do. I did not finish the study guide last period, and I'm currently recording on Zoom. So what I'm going to do is I'm going to kind of go through this backwards with you guys. I want you to go to number 9 on the practice portion of your study guide. Number 9, just so I can finish my YouTube video. And whatever we don't get to class today, you'll be able to look it up online, okay? So number 9, 10, and 11. Ready? Okay, number 9. Draw a nucleotide. Label the phosphate, sugar, and nitrogenous base. Okay, you could have drawn this easy way or a little bit of the hard way. Here's the easy way. P for phosphate, S for sugar, N for nitrogenous base. Now I want you to take a look at that nitrogenous base. Does it have 2 rings or 1 ring? 2. So is it a purine or a pyrimidine? It's a purine. What are the possible purines it could be? It could be adenine or it could be guanine. Now, here's the little bit more sophisticated way to draw it. Either answer will be acceptable. There's the phosphate group. There's the pentose sugar. There's the nitrogenous base. Are there any questions with number 9? Okay, number 10. Draw the structure of a general amino acid. All right, let's do that first. Label the carboxyl group. Which one of those is the carboxyl group, Andre? The right side. Yes, that is C. Look at this. C-O-O-H. That's what we call it. C-O-O-H. That is the carboxyl group. The amino group. Nikita, which one is the amino group?
The one on the left.
NH2. That's right. And the variable R group. Variable means it can change. The R could be a lot of different things. That's what makes them different. Now it says draw another amino acid and link them together. Label and describe the bond that holds them together. Okay, fine. Here we go. Now, this is a concept I didn't plan on teaching you guys because this is not a straight up biology class, but it wouldn't hurt to know it. Those of you who have taken bio should know this. Inside that red box I just drew, I have 2 hydrogens and an oxygen. What type of molecule is 2 hydrogens and an oxygen? Water, H2O. If you remove that water, it's gone. Carbon and nitrogen can now bond together. What type of bond is this? This is known as a peptide bond. A peptide bond is simply a covalent bond linking amino acids. Now, if you remove water, you form the bond. How do you break the bond? You reintroduce the OH and the H. You okay, Nikki? Any questions on 10? All right, let's go to 11. Last one. Describe and define the 4 levels of a protein structure. Okay? Number 1 is the primary structure. This is just a chain of amino acids. I mean, seriously, it looks like this. Every different color I'm using is a different amino acid. And they're all linked together. All right, that's the primary structure. Number 2, the secondary structure. The chain begins to twist or fold into its functional shape. I tried to describe to you that proteins look like big piles of confetti. They're all just a bunch of squigglies and twisties, and it looks really weird, but they have to be in a very specific shape to do their job. So there's 2 different types of structural secondary structures. Do you recall what they are, anyone? Emma?
Like the alpha helix.
Okay, so let's draw an alpha helix. This is the Greek letter alpha. An alpha helix basically looks like this, guys. It's like a spring. And what's the other one? Sebastian? A beta pleated sheet. It looks like a folded piece of paper. This is just the protein starting to bend and fold and twist to become the shape that it's supposed to be. If you don't get how this is, think of a folded piece of paper. I know I can't draw 3D, but I'm trying. It's like when you fold up a piece of paper to be like a fan, and you just kind of fan yourself with it. Number 3 is a tertiary structure. Tertiary is going to be the functional shape is 3-dimensional. The functional structure, let's do structure instead of shape, of the protein is 3D. And finally, the quaternary structure is just multiple polypeptides bonded together. And that's it.